Alright everyone, welcome back to episode 2 of our series on additive manufacturing and rapid prototyping. Today's topic is fused deposition modeling. And as we listen to Pachelbel's canon in the background, let me apologize for taking so long to release the second episode. That's not going to happen again. You see, what happened the first time is my sponsors, Grow It, moved. They were located in Anaheim, California. They are now located in Lake Forest, California. So if you are in the Southern California area, please stop by their new location. Otherwise, visit their website at www.growit3d.com. And just for the record, if you guys haven't heard of Grow It yet, you need to get off the stupid train, people. No, I'm just kidding. Could you imagine if I was like that? But seriously, they will help you with all your rapid prototyping needs. There is no sense in going out there spending hundreds of thousands of dollars on equipment. Simply email them your CAD files and let them do the dirty work for you. Alright, you guys, are you ready to talk about fused deposition modeling? I know I am. But seriously, calm down so we can get started. Fused deposition modeling works as such. You have a spool of material which is then melted and extruded through this tiny nozzle. Your material options are ABS plastic, a blend of polycarbonate and ABS, and pure polycarbonate. Some of the advantages of fused deposition modeling grown parts are the material options, the fact that they are warp-free, and the price. The disadvantages that you'll face are resolution and time. So let's go back to the beginning and talk about these. Material options. These are not simulants, so it's not a resin-based simulant like you would find with stereolithography. This is a pure ABS material or a pure polycarbonate material. It can pass FDA regulations. It can be used as an end-use part. So that's the materials. Let's move on to why they are warp-free. Because it's not a resin-based technology like some of your other options, there's no curing process. The curing process is what causes parts to warp over time. Anytime you're dealing with a curing process, your part technically never stops curing. So if you put it out into the sun or if it's exposed to heat, it might start to warp on you. That's not the case with fused deposition modeling, as this is a pure material, not a resin-based material. And then I also mentioned price. The machines are generally less expensive than stereolithography machines or selective laser sintering machines, and the material that goes into them is generally cheaper as well. So if you go to Grow It and you want a large part made, fused deposition modeling is often going to be one of your most cost-effective options. Now onto the disadvantages. Resolution. The X and Y resolution on fused deposition modeling is pretty good. It's just going to trace right around your part on that X and Y axis there. However, the Z resolution, which equals the layer thickness, is not so favorable with fused deposition modeling. Generally, it's 10,000ths of an inch, or perhaps you can move it down to 7,000ths of an inch or 5,000ths of an inch, but generally it's 10,000ths of an inch. If you go lower, the time increases dramatically. Now let's compare that to stereolithography, which is 3,000ths of an inch, or polyjet, which is 1/2 of 1,000th of an inch. So on the Z-axis there, you're going to see a lower resolution, which is going to result in stair-stepping. So if you want a very aesthetically clean-looking part, and you're using fused deposition modeling, it's going to require some bondo, some sanding, and some extra finishing work on Grow It's end, or on your end, to basically get it to look as pristine and nice as a different technology might allow. And then also I mentioned time as a disadvantage, which again relates to that layer thickness. Fused deposition modeling is one of the slowest processes out there compared to stereolithography, SLS, Polyjet, Z-Corp, the rest of them that I'm going to present on. Fused deposition modeling is incredibly slow. So for that reason, sometimes very large parts can take even a few days to make. So it really kind of takes the rapid out of rapid prototyping in some cases if you need a next day turnaround on a very large part. So those are your advantages and disadvantages to keep in mind with fused deposition modeling. And yes, I am intentionally making this soundtrack as hilariously awkward as possible because I need to keep you on your toes so that you can learn about sparse mode. When you're building an FDM, you can choose one of two modes, fully dense mode or sparse mode. When building in sparse mode, the interior of your part has this honeycomb-like interior, which, when you consider that FDM is one of the slowest processes, considerably decreases the amount of time required to build your part. So if you want to save even more money, you should consider building in sparse mode if durability is not critical. But keep in mind, this is an ABS plastic or some kind of polycarbonate material, so it's already going to be pretty strong, even if it is built in sparse mode. Alright you guys, that does it for fused deposition modeling. Please pass the word around, send this link to your friends, post it on your websites. In order for me to continue doing this, I need you guys to be viewing it, so please help me to help you. Check out Growit, www.growit3d.com. Use them, they are amazing. I will see you guys next time.